So we'll be looking at the relationship between linear velocity and angular velocity, and after that we'll look at some questions. We have 2 questions here to solve as an example. So let's go into this, the relationship between linear velocity which is v, and angular velocity which is omega. So looking at this relationship, and we actually derive. Now first of all, we should know that the angular velocity, the linear velocity, is given by linear velocity v is just maybe distance over time, and then angular velocity, the formula for the angular velocity is just angular displacement over time. So what is this angular displacement? Angular displacement, let's take for example, if we have, let's say this is a circle, and this is the center of the circle. Let's say the body is at this position x, so it will have a radius r. This body moves from here to this point here, y, then the radius comes to this place here. So this angle here has been traced, that's been formed due to the movement of the body position on x to y, is the angular displacement. And then the distance from here is denoted with s. So in this case here, we can say the angular displacement theta is equal to s over r. So angular displacement theta is s over r. In this case here, we can cross multiply. We cross multiply, here we have s is equal to r theta. So the next step is, let's call this step 1, call this step 2. The next step is you divide both sides with time. So divide both sides with time. So divide both sides with time. So we have s equals to r theta. We are dividing the both sides with time. So in this case, distance over time, remember from this formula here, distance over time is v, linear velocity. So come back and take it to v is equal to displacement over time, angular displacement over time is omega. So we have rw. So this is the relationship between the linear velocity and angular velocity. The linear velocity, the unit of linear velocity is meter per second, and the unit of angular velocity is rad per second. So note the both of them are the radius. And then, so let's look at this example very quickly. Here we have, if a ball is traveling in a circle with diameter of 20 meters. So here we have solution, and then remember, you bring out your parameters first. You bring out, when solving physics questions, bring out your parameters. So from here, our parameters were given a diameter of 20 meters, and then what else again? The velocity. With the velocity, the linear velocity is 40 meters per second. So then calculate the angular velocity. So we have to look for the angular velocity. So we'll write a formula that relates v is equals to rw. So you can see that we don't have r, but we can get r is equal to what? Diameter over 2, so which is equals to 20 over 2, which is equal to 10 meters. So we can now put in our values here. So v is what? 40 is equals to r is 10 omega. So therefore omega is equal to what? 40 over 10, which is equal to 4 rad per second. So this is how to solve this one for this question. Bring out your diameter, your parameters, put in your formula, get your r, and then you solve for omega. Put your v is 40, r is 10, and then make this subject a formula, you get it. Now to the second question. we have what will be the angular velocity of a rotating top. I think I'll solve this in the next video, so don't forget to like, share and subscribe, and check out the next video for this solution.